All right, thanks everybody for coming out. I got a lightning talk, so I'm gonna go a little bit faster. So I'm not gonna go through all of my bona fides. I'm just gonna say I've been doing software development for about 30 years, and I've been with Michelin for about 18 years, and my current role is Chief of Architecture for Business Solutions in the Americas. So today I'm gonna talk about Throughput, which is the game that I created basically to teach some important concepts in software development. So kind of what happened is about 3 years ago, I really got in my mind, I started thinking about why is software development, especially in the corporate structure, so inefficient, right? If you think about it, when we make tires, when we manufacture other things, the process is super scientific, right? When we make a tire, it's full of automation, we measure every process, we measure scrap down to the gram. We are just very, very orderly when it comes to making tires. And when it comes to making software, it's completely artisanal. It's like we make it up. It's like we start from scratch every time, right? And so I started thinking about it, and that led me to learning about the theory of constraints. And so if you're not familiar with the theory of constraints, basically it's a theory around manufacturing systems usually where you find the constraint in a given system and you leverage that constraint basically to manage the speed of delivery and the throughput of material through a system. And so I started reading about that. I got super interested in it. I was like, all right, well, how do I address this with software development? How do I use this for software development? And so I decided I was going to write a book, right? And so for all the people here who have written books, which I'm impressed by the number of people who have written books, it's really hard. And so, I looked out and found that Gene Kim had written a couple of books on the topic where he takes the theory of constraint and some of the other manufacturing systems and he applies it to software development. And so if you've never read the Phoenix Project or the Unicorn Project, I highly recommend it, especially if you're in a corporate setting. It really does go through what are the best practices to improve basically your delivery process. So next I said, well, I'm just gonna turn it into a lecture, right? I'll turn it into a lecture, I'll use it with some of the other software architects and see how that goes. Well, I gave it at our Worldwide Software Architects Conference a couple years ago in France. It was 2 hours in a hot room after lunch with predictable results. So it's back to the drawing board, and I said, how can I teach this lesson where it starts to get some traction, where it could be interesting for people? And so I came up with, and that's actually like the third alpha version of the game. So I came up with a game called Throughput. And so I started on paper, I used it on some of my colleagues, everybody was super engaged, and so I said, well, let me code it then. So I made a command line version first, and then secondly, I converted it to a JavaFX version because I'm a Java developer. I needed something I could rapidly prototype, and so it's in Java. And so now I'm gonna take you through the game. So basically, like any of these other productivity games, the goal is to get as many work items through to the finish bucket at the end. And the finished work items start off worth 3 points. They can go up in points based on certain activities or practices that you use. And work in progress is worth negative points. And the negative points grow as they go through the system. So as you add value to a product, right, you have more and more money trapped in the system, so the value goes up. And until it actually gets converted to a finished good, it's worth negative points to you. And so it's to represent the money trapped in the system until you finish a feature, until you finish your product. There's 5 workstations, each get a random capacity at the beginning of the game. It's limited. Usually I pick the number of the number on the die face. So 6 is the maximum, 1 is the minimum. And then each workstation has a matching server. And so the color of each server basically matches the color of the workstation, and we call that a skill, right? So you start off with 5 servers, each with a different skill. At the beginning of each week, the team decides how much goes in the backlog, hopefully looking at the capacity of their workstations to see how much can make it through. And then at the beginning of each day, they'll roll for team mood. And that basically says how many they can take from the backlog to start their day. So the first week you play in vanilla mode because we just want to get teams used to taking items through the system. At the beginning of the second week, you start to get into strategy and into some of the other play. And so you have boosters, inoculators, and traps, which are represented by cards that the team will draw as they go through the game. The booster are rewards for good behaviors. Inoculators are protections against security traps usually, so it's against security vulnerabilities. And traps, of course, are the bad things that can happen to any team, and it can be internal. They can be internally driven or externally driven. So each day, each workstation draws a card. They draw their chance card, and they can either fail for the day or they can succeed for the day. If they succeed for the day, they can move up to the capacity of their workstation through to the next workstation. The ratio of the chance cards is programmable. So depending on how hard you want to make the game, we can reduce the probability of success or we can increase the probability of success. I default to 90%. So you have a 90% chance of success to get your work done for the day. And then one of the other features is that at the beginning of the second week, you can begin to put servers into training in order to allow them to gain new skills. And so because you can, after the second week, you can start to move servers around, but first you have to send them to training. And when you send them to training, they lose a day of productivity, just like in the real world, and then they gain the skill, and then they can go back into circulation. Once one of the servers has gained a skill, they can then move to various workstations depending on the needs of the team. Here's some examples of some of the booster cards. In the case of a team that puts functional metrics in place, where now they can gauge the use of various features that they've added to their product, and they actually know the behavior of the end users. So that increases the value of your finished goods, right? Because you know your features are being used, and you know the features that people really like and appreciate, and you know the features that people are ignoring. And so this increases the value of finished goods. If you do regular patching, it mitigates a security vulnerability. It doesn't get you out of a security vulnerability, so there's some where you lose a day. There's other security vulnerabilities where you lose a week of productivity. And so if you lose a week, it might take you down to a day. If you lose a day, it might take you down to, you just lose one workstation's worth of productivity. Fitness functions, this is one of my favorite ones because this is an architecture principle. So fitness functions are basically where you put in place things like unit test coverage, a rule about unit test coverage. When the team goes to deploy, if coverage drops below 80%, the deployment is off, right? And so we have a number of fitness functions that teams can implement. And for things like this, you get a do-over. And so if you have a 90% chance of success for the day, a do-over basically gives you a 99% chance of success for the day. So this is an example of a trap. The team gets a Sev1, it's all hands on deck, so nobody's delivering features that day. So the team loses a day. And then defective work items. So in the case of defective work items, any of the items in a particular workstation have to go back to the previous workstation to be reworked. If you get defective worked items and finished goods, you just lose those goods. So you lose all your finished goods that you've produced so far for the week. And then The next one up is automation. So in this case, if the team engages a site reliability engineer to automate one of their workstations, there's only a fixed number of workstations that you can automate. So just like real life, you can't automate every task. So there's some workstations that you can automate. So if you automate a workstation, now you basically double the capacity. So if you leave the human server with the automation, you double capacity. But it also gives you the ability to move that human server to another workstation, of course, once they've been put into training. There's also the ability to gain a pair. So if you choose to implement pair programming, you can get you can pair the paired programmer with one of your workstations as well.
Right in time.
Okay, so all right. So here's the two main lessons that we want to that I want people to learn is that the total throughput cannot exceed the capacity of the slowest workstation. So if you have a workstation that can only do one in a 5-day period, you can't move more than 5. And the other one is the probabilistic nature of success. So if you have 9 workstations that have a 90% chance of success, you only have a 60% chance of success for the day. So if you think about that, for any dependent processes you have, success is multiplicative. And so break dependencies where you can and raise that 90% as much as you can as well. All right, so sorry. I went a little bit farther than I thought. So sorry, before I go, I did have one ask. So on here, I'm open sourcing the game, and so I would love it if people want to contribute, if they want to contribute ideas, if you want me to host the game or something like that. So if you take my email address, I'm still in the process because it is a corporation. I can't just open source it. I have to go through a lot of hoops. Send me an email though if you're interested, and I'll send you the link once it's open source. All right, thanks.